So let us consider the second example. Obtain the particular solution for the following differential equation using method of undetermined coefficients. Y double prime minus 9y is equal to x plus exponential 2x minus sin 2x. You can see from this that it is what is a second order non-homogeneous. And whenever we have a second order non-homogeneous, it means we are using a method of what undetermined coefficient to solve it. That is, we consider a two solution, that is particular solution and the general solution of the homogeneous. So since you know that our y double dash will give us m squared exponential mx, then our y is what? Exponential ms, and then our y prime is what? M exponential ms. What we need here is this. We just plug in this. That is, we have to solve the homogeneous part by this. Solving we have to solve the homogeneous form. That is y prime minus 9y is equal to 0. Y double prime minus 9y is equal to 0. So what's our y prime here is what? M square exponential mx minus what's my y? My y is what? Exponential ms is equal to 0. I will divide both sides by what? Exponential ms, then exponential ms. So this will cancel. I'm going to have m square minus 9. There is 9 is equal to 0. So here I'm going to have m square is equal to. I will now take my negative 9 to the right hand side because this is constant and constant. So I'm going to have 0 plus 9. I'm going to have m square is equal to what? 9. So what am I going to do is what? I will solve the what? I want to get what? I want to get my value for m. So for me to get my value for m, I have to take the square root so that I can get what? M. So I take the square root, I'm going to have m square is equal to root 9. This will cancel. I'm going to have plus or minus. So I'm going to have m is equal to plus 3 or m is equal to what? Minus 3. You can see that I can do that to be m1, m2. You can see that m1 and m2 they are not equal to. This is a case 1. That is when we have a real root distance if it is not equal to. And the general solution of this, if it is not equal to, I'm going to have what? I'm going to have my y as what? A exponential. This is what? Our one is what? 3. 3s plus b exponential minus 3s. I can set a should be any value because a is a constant. I can say a should be c1. C1 exponential 3s, or I can say it should be what? It should be c2. It should be r1, r2. Since a is a constant, so it means I have solved y of what? I've solved what? Y_c, that is the solution of the what? Of the homogeneous. So now is what? Because from solving our method coefficients is a technique, that is our yc, our y will be what? Yc plus yp. It means y is equal to yc. Our yc is the what? The homogeneous, the solution of the general solution of the homogeneous, which is this. So I will now solve what? Yp. So my yp will now be I will now consider x exponential 2s minus sin 2s. Why? Because yp is my particular solution of the non-homogeneous. You can see this is not. This is first. We have x here. We have exponential 2x here. We have minus 2x. It means I'm going to consider a solution for x. I'm going to consider a solution for what? A particular solution for exponential 2x and a particular solution for what? Minus sin 2s. So let us start from x. Since my g of x here is what? My g of x is x. I think my g of x here is x. I'm going to consider my g of x here as exponential 2x. Then my particular solution of this is, remember that the complementary factors of g of x, whenever I have x, what did I say? If I have x here, I'm going to have what? As plus b. Remember that I said if I have constant, my complementary factors of my constant, 5 is to be what? A. Then if I have s to the power of 2, my complementary factors of s to the power of 2 is what? As squared plus bs plus c. That is, it will start with the power that we are giving, that value we are giving to the constant. So that's why I'm going to, so my y of 2 will now be as plus b. So it means I want to get solution. I want to get what is A and what is B. When I get what is A and what is B, it will be my particular solution for this. So it means I have to differentiate. I will differentiate this, the particular solution. If I differentiate this with respect to x, I'm going to have what? A plus 0. If I differentiate again, I'm going to have what? 0. So I will now consider this. I'm going to have y prime prime minus 9y is equal to what? X. Y prime prime minus 9y is equal to x. Since I'm dealing with x, I'm going to take this and x. If I'm dealing with exponential 2x, I'm going to consider this and exponential 2x. If I'm dealing with the last term, I'm going to consider this and the last term. So I don't need to write everything because I'm dealing with the particular solution for x. So I'm considering this, the homogeneous, the left hand side and x. If I'm dealing with exponential 2x, I'm considering the left hand side and the exponential 2x. Not including this, not including this. So what's my y prime prime? So my y prime prime is what? 0. My y prime prime is 0. My 9 is what? 9y. What's my y? Ax plus b. Ax plus b is equal to what? X. So I'm going to have minus 9ax minus 9b is equal to x. So from here, I can equate this. It means I can equate this minus 9a. So what is beside a? What is beside minus 9a? We have x here and x here. I can equate, since this, I can equate s as coefficient of 1, constant term. As since minus 9ax is here, I will equate this to 1. Equate the constant term. That is, the constant term here of this here is 1. Minus 9b. Do we have something related to b here? No, we don't have. It's 0. Because minus 9as, we have x here. That's why I equate this as the coefficient of the s is what? 1. So from here, I can get my a. From equation 1, this is equation 1, this is equation 2. So I'm going to have what? Minus 9a is equal to 1. Divide both sides by minus 9. This will cancel. I'm going to have a is equal to what? Minus 1 over 9. It means my a is equal to 1 over 9, then my b is equal to what? 0. Because if I put this on, I'm going to have 0. So I will now go back to my what? To this particular solution. So I can, since y of p, I want to get y of p, I can say it will be y of p1, particular solution 1, because we have another one here, So I'm going to have yp1 is equal to what? What is my a? S plus b. What is my a? My a is minus 1 over 9. Then multiplied by s plus b plus 0. So it means my yp1 is what? Minus 1 over 9. 1 over 9x. So let us now consider, so I have to consider my what? My second part, that is exponential 2x, my second term. So I will now have g of s here is what? That is I'm considering what? Exponential 2x. So my g of s here will be what? Exponential 2x. So what is the complementary factors of exponential 2x? Remember that I said that whenever I have exponential, I'm going to have that exponential as my complementary factor. But here, the coefficient of exponential 2x is 1. And whenever I have a constant, I'm going to have a. So I'm going to now have g of s is equal to a exponential 2x. So since my g of s is what? Is a particular solution. So I don't need to write g of x. So it's not be my what? My yp of 2. Because my yp1 is what? My yp1 is a. This is my this is my first particular solution, second particular solution, and third particular solution. And I want to get this, So I will now consider my second particular solution as 2. I will now differentiate y prime of p of 2. I'm going to have what? With respect to x, 2a exponential 2x. I will differentiate again. I'm going to have what? 4a exponential 2x. So I will now consider this equation. Y double prime minus 9y is equal to what? Exponential 2x. Because I'm dealing with what? I'm dealing with the second term. I want to find the particular solution for the second term. I don't need to take the first and the third term. Because I'm dealing with the first time, to find the solution for the first time, that's why I take only first time. So I'm going to have, what's our y prime here? I will substitute 4a exponential 2x minus 9. What's my y? My y here is what? A exponential 4x. A exponential 2x is equal to what? Exponential 2x. I will divide both sides by what? Exponential 2x. this will cancel. It will cancel here. It will cancel. I will be left with 4a minus 9a is equal to 1. So 4a minus 9, I'm going to have what? Minus 5a is equal to 1. Divide both sides by minus 5. I'm going to have what? A as what? 1 over minus 5. So I will now go to my what? My particular solution 2, that is a exponential 2x. So my yp of 2 will now be what? A exponential 2x, which give me 1 over minus 5, or 1 over minus 5 a, since my a is exponential 2x. So I will now know what? Our last one is what? I will now consider what? Minus sin 2x. Exponential 2x all over 5. Since 1 times exponential, this one is 1 over 5, 1 minus 1. So I'm going to have minus exponential 2x all over what? 5, or 1 all over 5 negative minus 1 over 5 exponential 2x. So let me now consider sin 2x. My final solution will now be my y as what? What's my y of c? That is the final solution. A exponential 2x 3x plus b exponential minus 3x. Then plus my yp1. What's my yp1 here? That is my yp1 is what? Minus 1 over 9x. Minus 1 over 9x, or minus x over 9. Plus, what's my yp2? My yp2 is what? This is my second solution. Minus exponential 2x minus 5. That is minus exponential 2x minus 5 over 5. Then my yp3 is what? My yp3 is what? My yp3 is what? Minus 1 over 3 sin 2x. Yp3 is 1 sin 2x, that is plus 1 over 3 plus 1 over 13 sin 2x. So it means this is my solution, my general solution for the what? For the second under, that is a exponential 3x plus b exponential minus 3x. That is my general solution for the homogeneous, minus my particular solution of 1, which is what? Minus 9 over x, or minus x over 9. My second particular solution, exponential minus 2x minus exponential 2x all over 5. Then the last solution, which is what? 1 over 13 sin 2x. So this is the solution for the question above.